Laxman sir, good evening. Welcome, sir. Can you hear me, sir?
Hello.
Can you hear me, Laxman sir?
Yes.
Welcome, sir. Welcome, sir. I am Thomas.
Okay. Thank you so much for inviting me.
Okay, sir. Okay. Thank you. Thank you very much.
So, when we will start?
We will start now. Now itself. It's now itself.
Now.
Some
Okay.
officially some 10 minutes only.
5:10.
10 minutes we have official program. Then after that we have the talk.
Okay.
Okay, sir. Okay.
So I will share my screen.
Sir, after the introduction. 12:15.
Okay.
Okay. Okay. Sneha, please.
Respected resource person of the day, Dr. Laxman Singh, Head and Assistant Professor, RRS College, Principal Dr. Shaila Abraham, Chemistry Association in Charge and Program Coordinator, Professor Dr. Thomas Baby, IQAC Coordinator, Lieutenant Renish Joseph, academia across the country, beloved teachers, and my dear friends. A warm good afternoon to one and all. It gives me immense pleasure to welcome you all to the national webinar on nanomaterials for 21st century organized by the Department of Chemistry in association with Internal Quality Assurance Cell, Kyriakos Grigorios College, Pampady. Let's commence with the praise of the most merciful and the most benevolent. I would like to call upon Sida Lakshmi AS, final year BSc Chemistry, for praise.
ഉദയസൂര്യനു മംഗളം നവവാസരത്തിനു വന്ദനം സകല ഭൂതലവാസിനും ജഗദീശ്വരൻ തുണയേകണം വിദ്യയും പെരുമാറ്റവും മമ ഹൃത്വപാഠശരങ്ങളും കൃത്യമാക്കണമേ വരും സുഖസൗഖ്യമാന്നു വസിക്കണം.
Thank you, Sida Lakshmi. Now, I would like to request Professor Dr. Thomas Baby, Faculty of Chemistry and Program Coordinator, to deliver the welcome speech.
Sir, mic mute. Anna.
Sorry. Good evening all, and a warm welcome to one and all the dignitaries and participants. Today, our department, that is Department of Chemistry, Kyriakos Grigorios College, Pampady, Kottayam, is organizing a national webinar in association with IQAC of our college on a highly relevant topic, nanomaterials of 21st century. All of you know why I am mentioning this as a relevant topic. Today, we can say every aspect of human being is shaping up by nanotechnology materials. Definitely, we could say that this is in a progressive manner. Probably you might have heard of natural nano wonders. What I'm telling natural nano wonders is that most of the nanotechnology applications are actually mimicking nature. Actually, God has given us a message that very, very tiny things are more powerful than complex and gigantic figures, actually. The department has immense pleasure to organize a national webinar that is actually discussing a current technology. Also, we are highly honored to get an eminent professor and researcher to deliver today's lecture. Dr. Laxman Singh sir is known to me for the last few years as a researcher, good academician, and moreover, very simple and humble personality that you could rarely observe in great researchers and scientists. He is the head and assistant professor of RRS College under Pataliputra University, Patna, Bihar. He had a lot of awards and recognition in his career, lot of international patents. That is really commendable, actually. He is also serving as editor-in-chief, editor, editorial board member, and reviewer of many internationally reputed journals. He has also presented lot of papers in international and national seminars in India and abroad. He also organized large number of national and international seminars. Sir also has a couple of international collaborators. He is an expert in the synthesis and characterization of material, especially the nanomaterials. Moreover, he is in charge of many programs, particularly the IQAC of the college, IQAC coordinator. We are really honored, sir, to get you here on behalf of our entire college community, chemistry department, and for the participants. I welcome you, sir, to this webinar. We are grateful to you for accepting our invitation, even in a hectic schedule of responsibilities. Thank you very much, sir. We have okay, thank you, sir. We have our IQAC coordinator, Lieutenant Renish Joseph, sir, with us. This time, I like to express my sincere thanks to him for his valuable suggestions and support for all the activities. I cordially welcome you, Renish, sir.
Thank you, sir.
I also like to congratulate and welcome students of our department for their active support, particularly Association Secretary Sinda Esther Reggie for her coordination, Sneha Rachel Biju, Treasurer, who is comparing this program, and the technical team members Amal Jobi and Agas for their sincere effort. Welcome you all. I think the participants are from different areas of country and from different universities and colleges. And I sincerely welcome all of them to the programs. I also welcome faculty members of our department, faculty members and students of other colleges. Once again, I cordially welcome each and every one of you to this webinar and request your active participation to make this webinar fruitful. Thank you all.
Thank you so much, sir. I would like to invite Lieutenant Renish Joseph, IQAC coordinator, to extend felicitations.
Respected Principal Dr. Shaila Abraham, teacher, our Chief Resource Person Dr. Laxman Singh, Chemistry Association in charge Dr. Thomas Baby sir, dear students. Firstly, I must congratulate Dr. Thomas Baby sir for organizing this national webinar. The classes offered in colleges only provides limited basic knowledge to the students. But talks organized by associations like this often provide additional knowledge to the students. My only request to the students is to not to remain as mere listeners, but to raise questions and to gather additional knowledge from this talk. And I once again congratulate Thomas Baby sir for organizing this webinar. And I presume this webinar is proven to be a great deal of knowledge to the students, and you gather most out of this. Thank you.
Thank you, Renish. Participants, please note, we care about your opinion. So the feedback form link will be available in the chat box. Please fill it out after the talk. As already informed, e-certificates will be provided to all participants. It's my great honor and pleasure to introduce our resource person, Institute of Science at IIT, and personally working as head and assistant professor, RS College, Pataliputra University, etc. He has been selected as National Research Fellow, South Korea. He published more than 54 research articles in well-reputed SCI international journals. Dr. Singh has been granted 5 international patents from Korean Intellectual Property Office from South Korea. Dr. Singh is editor-in-chief of Journal of Materials, Processing and Design, editor of International Journal of Chemistry and Applications, USA, and current Nano Materials guest editor and editorial member, USA. editorial board member of almost 15 international journals published from USA, Singapore, UK, Canada, and many more. Dr. Singh acts as a reviewer of scientific proposal and referred journals more than 25 such as Journal of Materials Chemistry, Progress in Crystal Growth and Characterization of Materials, Materials and Design, Material Science in Semiconductor Processing, etc. He has extensive research experience on synthesis and characterizations of nanomaterials, metals, mixed metal oxide, peroxide oxides, ceramics energy-related peroxide materials for lithium-ion battery, fuel cell, capacitor, supercapacitor, etc. It's so impossible to mention his every single accomplishment because they are lot. However, today we are here to recognize his outstanding talents. It is such an honor for us to have you today amongst us. I humbly invite you, sir, to lead this session. So please.
Thank, thank you so much. Good evening to all of you. And I especially thank to Dr. Thomas Bibi and Lieutenant Vani sir for inviting me to uh, deliver a lecture to in this webinar. It gives me a great pleasure to welcome you. I hope all you are in our thoughts and prayers with you and your family. During this pandemic, we have learned lots of this pandemic because we are organizing a lot of seminar, webinar, and we have to lots of learn about the online study. So at the opening of this national webinar on nanomaterials for 21st century, I extend to very well welcome to all participants in this webinar organized by Department of Chemistry, KG College, Kerala. I congratulate to Dr. Thomas Bibi, Department of Chemistry, together the prominent participant on this platform. As we know that the, can I share my screen?
Yes, sir. Yes, sir. Yes. Sir.
Everyone can see my screen.
Oh, sir. It is visible. Visible. Visible.
Now it is visible.
Yes, visible. Visible.
Hello. It is visible. Okay.
Okay, sir. Visible.
So visible. Okay. Okay. Thank you. Thank you. So this national webinar will be enabled to faculty members and research scholars to provide the knowledge how the nanomaterial change our daily life. Do you know that the whenever the BSc MSc student and research scholar ask that what is nanomaterial? So today's life depends upon the most advanced technologies are there. These advanced technology come from the various countries from Japan, South Korea, USA, other things. So everyone is curious about the nanomaterials, and these nanomaterials change the whole world. Means in everywhere the nanomaterials are present today and day-to-day life because they play a key role in modern and sophisticated life and significantly contribute the human civilization to till date. With growing the demand of these nanomaterial, enhancing the knowledge and technology in agriculture and medical field and electronic field and lots of area they are developing for the nanomaterials. The pharmaceuticals industry and pesticide industry and there are lots of industry are involving in the case of the nanomaterial. So for the 21st century, we are using the nanomaterial. Nanomaterial. These are the two different things. Nanomaterial and bulk material, these are the two different things. So today I deliver that what is nanomaterial, how they are useful in our life, how they synthesize, how what is the use of these nanomaterial in energy storage system, because energy storage is very comfortable in our modern life. Whatever we use, the mobile phones, electronic device, laptop, and each and everything we need the energy to run these devices. So how these nanomaterial change our today and modern life, how nanomedicines are there, so nanomedicines, and this changes our life, day to day life. So everyone know about the uh, in this 21st century, nanomaterials are very important. So 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 first is, what do you mean by nano? So everyone know that nano. Nano is taken from the Greek word nano. Nano means dwarf, extremely small. Means the materials and is very small in size. Is known as nano. This nano word can be derived from the Greek word means nanos. And do you know how big is nano? Can you define that in meters, centimeter, kilometer? These are the units for the land. If we can talk about the nano, nano means 10 to the power minus 9. 10 to the power minus 9 is known as nanometer. In human being, if we talk about the hair, it's almost the 50,000 to 80,000 nanometer thicker. If a fingernails grow in 1 second is equal to the 1 nanometer. It means this is the biological as some example of that. What is the nano? So nano what? Nano is derived from the Greek word from nanos, and we know that the nanoparticles means the particles or material whose size is 10 to the power minus 9. So understanding it, because how we can nanoscience. Nanoscience means the everywhere, chemistry, physics, biology, everywhere is nanoscience. What nanoscience and nanotechnology? These are the different. Nanoscience means whatever we study the nanomaterials, whatever we study the biological things in nanometer scales, it is a nanoscience. What in common part, if we are developing the nanomaterial, we are synthesizing the nanomaterial. So nanoscience means it is the study of the small particles, small material in nanometer range in the size of 1 nanometer to 100 nanometer. If we are talking about the nanoscience means the particles having the range between the 1 nanometer to 100 nanometer. There is a difference between the nanoscience and nanotechnology. Nanoscience means we are studying the nanomaterials. We are studying the materials whose size between the 1 nanometer to 100 nanometer. But in the case of nanotechnology defined as we have to use this material in the form of industrialization. Means nanoscience means we have to provide such a material which is will be beneficial for the human being to make a sufficient life. So nanoscience and nanotechnology is a little bit difference. Nanoscience means we are studying that stuff which is size is 1 nanometer to 100 nanometer, but nanotechnology driving that nanomaterial to directly for the industrialization, commercialization of that material. Means nanoscience is flourishing, the nanotechnology is the infancy stage. Nanomaterial world. What is nanomaterial world? Nanomaterial world means it is a bridge between the our world and the smaller world of atoms. We know that atoms are very small in size. We cannot see. So these are in nanometer size. So our world and the atomic scales, materials, they are the bridge between them. So we studies the only nanomaterials which are in size between the 1 nanometer to 100 nanometer. So there is a large number of area where we are used to study the nanoscience and nanotechnology. Physics, chemistry, biochemistry, biology, biotechnology, microelectronics, information technology, material science. These are studying nanoscience and nanotechnology. It is not restricted to biology or physics and chemistry. Whatever the science, whatever the subject that work with the very small materials within the range of 1 nanometer to 100 nanometer, that area includes the nanoscience and nanotechnology. Whatever the area, we are using studies 1 nanometer to 100 nanometers. Every area is coming within the nanoscience and nanotechnology. Research on nanometer scale is not new at all. We know that the modernization will come with the expertization, with the various instrumentation. In uh, modern time, there is a lots of instrumentation. We calculate the size and other thing also. But in ancient days, we don't have the instrumentation which provide the size of the material such as scale, pin, etc. But this area is not new because almost 1000 AD Chinese used to collide gold to give the red color to their ceramic porcelain. There are lots of ceramic porcelain are there. They design with the colloidal gold on them. For this colloidal gold are in nanometer scale. Although in 1857 Faraday prepared a colloidal gold, it is a nanometer scale. It was stable till. Colloidal gold was still used for the treatment of arthritis. It means the nanometer scale or nanometers are not new for all, but at that ancient time we don't know the size of these material, but the in modernization, the growth of the different physiochemical characterization are there. So we know that what is the size. Uh, Ancient days, these stresses are also be there, but at that time there is no instrumentation, so the people don't know about the what is nanometer scale, what is the size of this particle we are using for the designing of the ceramic porcelain etc. So why there has been sudden increase in interest in this colloidal particles? Hmm. We can see the image engineering and manipulation and nanometer scale. Actually, these colloidal particles have the size in micrometer range, but we have the different technique for mechanical and other. We can change these colloidal particles into the nanometer scale system, which are very useful in the various area. Now, whatever in modern science, we have a different
You are not so audible.
physiochemical characterization. My voice is clear? Hello?
Yes, sir.
Hello?
Yes, sir, it's
My
clear.
voice is clear. Okay. There is something, interruption is there. Someone asked me something. So okay. So now this is a modern age. In modern age, there is a lot of instrumentation are there. Uh, discovered one by one. Progress is there. First, 1984, there is the electron microscope where we can see the collided particle are movement in zigzag motion. They are very small in size. And after that, around 1985, there is a three instrumentation are discovered, same 10 and AFM, scanning electron microscope, transmission electron microscope, and atomic force microscope. These microscopes are very useful for the characterization of the nanomaterials. If we synthesize in our lab any material using the various synthetic matter, various chemical rules, but how we say that this material is a nanometer in range, nanometer in size. So these instruments are very useful to characterize them same, tame and away. Scanning electron microscopy, tame electron microscope and atomic force microscope. In 1992, 2000, neuroscience protein developed. In 10 years, 1990 to 2000, neuroscience is developing is, but after 2001, this nanoscience is developing towards the nanotechnology because these nanomaterials are commercialized after the 2001 because most of the nanomedicines and nano electronic devices are coming from one by one. So these nanomaterial having the size between the 1 nanometer to 100 nanometer, having the uh, various different properties, physical properties and chemical properties from their bulk material. Because these at atomic scale, the properties are entirely different. They show the very unique properties of electrical, magnetic, and other form. So these nanometers are entirely different from the work material. So micrometer size properties always showing the bulk properties, but if the material in nanoscience, it doesn't show the bulk properties. The size of nanomaterials is similar to the most of biological molecules and structure in our body. There is a large number of molecules. We are there. They are metal. These molecules are in also in the size of nanomaterials. The surface energy of nanoparticle is very high. We know that the surface area will be increased when the particle size is very small. So these surface area and other things, uh, physical properties of these nanomaterial is different. So surface area is very useful for the catalytic property of material. So nanomaterials are always used as a nanocatalyst as in various industries, biodiesel industries and other form. So nanomaterials are entirely different from the bulk material because at atomic scale they change their physical properties into the very unique and desirable properties um, such as catalytic properties, magnetic properties, electrical properties. They are very entirely different from these bulk properties. So Uh, for example, bulk semiconductor become insulator when the dimension in the nanometer size. The bulk semiconductor become insulator when we change the device size into nanometer range, and also gold does not exhibit the catalytic property, but indicates when in a gold in nano crystal form it shows the very good catalytic property at very low temperature. So, why is the study of nanoscience different from the same problem of macroscopic scale? As I discussed there, in nanometer scale, the physical properties are entirely different. This is not possible at the macroscopic scale. So there are the various areas of the nanotechnology we are using nowadays, and in upcoming years we are using these nanomaterials and nanotechnology in various fields. So medicine, in the case in the area of medicine, various diagnostic system used as the gold nanoparticle for HIV, anthrax, E. coli. Drug delivery system also using nanoparticles. They in the drug delivery system or nanomedicine they are using there. They have a high absorption, and these nanomaterials are attached with that particularly targeted area. So in the drug delivery system, the nanotechnology also useful. Tissue engineering, nanofibers of hydrogel peptide also used in tissue for the bone transplant. We bone transplant, nanofiber hydrogel, nanohydroxyapatite, they are using nanoscience in nanomaterial particles. Carbon nanotube also used as for blood coagulation, quantum dot, intercellular imaging, etc. For the environment, nanotechnology also be there. Nanoporous membrane with 10 nanometer pores used for the filtration. We are using also the nanomaterials for the detection of mercury, arsenic at very low level, and the magnetic nanoparticles like iron oxide also used to water wastewater treatment for the magnetic particle separation. So there are various use of the nanoparticles and nanomaterials in nowadays in everywhere, in medicine, environment, also in the electronic device, such as memory storage. We use this nano size material for the development of integrated circuit. As we know that the various novel semiconductor devices data storage capacity in GB rays and terabyte array, and novel optoelectronic device using quantum dot. Also, we use the display system and with low energy USCNT for OLED and LED system. So we know that during the ancient time there is a world computer is there. When the Charles Babbage is there, he was using a room for the computer. But nowadays we are seeing that the using the tablet, using the smartphones, they have the we are using the memory system. With, in 2010, 2004, we are using a very large hard disk having the 400 and 500 GB. But nowadays we are using the very cheap memory card. We are using that very small, very cheap memory card having the weight between the 2 to 5 gram and 10 gram. We are using that having the high capacity like 500 GB, 1 terabyte. So this is possible due to the nanomaterials because each and everywhere nanomaterials uh, minimize the size, minimization of the size of the electronic devices because they using the very small in size nanomaterial in the capacitor and other form. They using the uh, devices and put there and the size in in minimized form you in various form because everything is in small, then we can combine them into the electronic devices and the weight height volume everything is very small and minimize their size. So this will be happen due to the nanotechnology. In heavy industry also, nanotechnology is used in aerospace. The heavy weight of the spacecraft will be minimized using the polymer containing nanoparticles. In catalysis, we are also using the various nanocatalysts. Nanocatalysis, the catalyst having the size in nanometer range they are using for the, because the nanocatalyze shows the various unique catalytic properties because they are used in very small amount. They have using the high surface area, and they are they are they are using as a lock and key hypothesis limits. They are using very small amount, and we recover these nanoparticles after the reaction in 100% regeneration of these nanoparticles. So in catalytic form, nanocatalysts are very useful because they are used very small in size. They are 100% regenerated. These nanoparticles after the completion of reaction, they also increase the kinetics of that reaction. Uh, then the bulk materials catalyst. So in nanotechnology, they are using most of the areas. Also, we use the construction like as Al2O3, silicon oxide in cement. Nanoparticles also used in steel, addition of copper nanoparticles. Nanoparticle also used in glass. TiO2 nanoparticle used for the glazing, breaking organic compounds. Also, we use the Si2 nanoparticles for the production of iron protective glass. Nowadays, in modern life, we are also using the various nanoparticles in the form of consumer goods. In food, we use the production, processing, safety, and packing of food. We are using the lots of nanoparticles are there. Nano food we are using canola active oil, nano tea, nano critical slim shake chocolate. We are using nanotechnology. Household device. This is simply self-cleaning, easy to clean surface of ceramic and glasses. Optics, textile, everywhere we are using the nanotechnology. Cosmetics, we are using the talcum powder, and they are having the various titanium oxide and zinc nanoparticles, and also in agriculture we are using the nanotechnology. They are using the we are using the agriculture and nanotechnology production, conservation, packaging, transport, waste treatment. We are also using nanomaterials used in the soccer, football, baseball, etc. Also fuel additive CO2, CO2 ceramic So nanomaterials there is a various application nowadays. There's cosmetic application, nano composite materials used as a mechanical, optical, electron device, nano coating, uh, nano coating, hard cutting tools, more powerful point, fuel cell, display screen, fuel additive, lubricant. They are the few examples we are using nowadays for the nanomaterials and nanomaterials in in modern life and day-to-day life we are using the lots of nanoparticles on that material. Nano electronic device and nano medicine I already discussed with them. So energy. So this is my research area, energy. So whatever I talk in that way, nanomaterials, what are nanomaterials, how they modernize our life, and what type of nanomaterial are used in our day-to-day life in various sectors like medicine, agriculture, electronics, where all of vast area we are using the nanomaterials. So energy also is one of these sector we are using the nanomaterials. So particularly I am a material scientist. working in the area of battery, supercapacitor, and capacitor fields. So I discuss about the how these nanomaterials change energy storage system what we are using nowadays. So these nanomaterials also reduction of energy consumption because whatever we are using, they reduce the electrical energy consumption such as when nowadays we are using the LED bulb. But first time we in previous time and before 20 years we are using the bulb having the element. They are using the high consumption electrical energy, and we also derive these solar cells. The efficiency of solar cell depend upon the uh, materials whose nanoparticles because they absorb the light energy, and the nanomaterials absorb the sunlight in very high efficiency form because they have nanometal increase the surface area of that material. So we these nanometal have to in the system to storage energy because they have the surface area. So now this is my topic that how these nanomaterials used in the modern age of science, particularly for the lithium ion battery. As we know that the we are everyone are using the lithium ion battery in the form of in smartphone, laptop, and torch, and various form we are using the lithium ion battery. Every portable device and other device are using the lithium ion battery. We know that the lithium ion batteries are very bright future in that because the heavy electrical vehicles and electrical vehicles are depend upon the lithium ion battery. We know that the lithium ion battery most powerful and most successful Tesla are using these heavy using develop the heavy electrical vehicles like cars and other. So the climate are changing because the fossil fuels are decreasing in amount. They are replicate, they are reduced, and they are also provide this various environmental effect. So we have moved into environmental friendly energy storage device like batteries, supercapacitor, capacitor, and so on. So out of them, the lithium ion battery the most developed for energy storage system for laptop, computer, and other forms. So most of the cell phones, digital camera, notebook, computers, TV, all of these devices using the nanomaterials, and these are also the example of today nanotechnology or modern life nanotechnology for the energy storage system. One of the research on lithium ion battery is going on for the to develop the materials for the heavy electrical devices because in heavy electric devices the lithium ion battery is may be used uh, because having the high capacity and stable thermal structure and other form because the most of the lithium ion battery the power capacity of the lithium ion batteries depend upon the cathode material. So in cathode material, the commercialized cathode material is using as a lithium cobalt oxide. As we know that the lithium cobalt oxide is used as a cathode material for the lithium ion battery. For the lithium ion battery, there is a cell consisting of the four part. First is positive electrode having the lithium cobalt oxide known as cathode. Negative electrode made up of carbon is known as anode. Also, there is a separator which is made of iron porous polymer film, and also electrolyte where the lithium ions are moving in that organic solvent. So, lithium ion battery, but the lithium ion battery capacity depend upon the that cathode material. This is the lithium-ion battery, where is cathode and anode. Cathode may particular made up of the lithium cobalt oxide, and the anode is made up of the uh, by graphite. They are the electrons are moving from anode to cathode. Whenever we discharge charging this lithium ion move to the anode. When the battery is discharged, the lithium ion move to from anode to cathode. That time they are releasing the electron. This is the charging and discharging process of the lithium ion battery. That is the charging discharging process of the lithium ion battery. So the I am discussing about the lithium ion battery. The capacity, whole capacity of the battery depend upon the cathode material of the lithium ion battery. So for the modernization, we use the lithium ion battery for the heavy electrical vehicles like truck and bus. But nowadays it is not possible. So we are discovering, we are searching for a new cathode material having the this requirement for the modernization, high practical specific capacity, high energy density, high cycle number, high thermal stability, and the cost of manufacturing cost also be low because it will be range between the normal people man. So it may be manufacturing cost also be low. Eco-friendly, eco-friendliness. We are using the lithium cobalt oxide nowadays, but in the cobalt it is a toxic element is there. So for the upcoming or modernization of the our lithium ion battery, the cathode material must have the high practical specific capacity, high cycle number, high thermal stability. High thermal stability means in 2016 or 15 we have had the Samsung Note 7. They have a lots of Note 7 having been catching fire due to the lithium ion battery because the cathode material is heat up and they produce a fire. So we have developed that type of material which is high thermal, so the high thermal stability. Whenever we charge the mobile, it should be heated. So it is due to the cathode material because it is not highly thermal stable. Also, so we have to develop the that material which have the high thermal stability, also eco-friendly stability. So nowadays we are using the lithium cobalt oxide, but what is the problem between the lithium cobalt oxide for using the heavy electrical one? There is two problems. First, the cost of that material lithium cobalt oxide is very very high, so we cannot use in the heavy electrical device because there is a lots of process schedule cost for the manufacturing of the anode, cathode, and everything. So that is a high cost of there. Second one is uh, there is a the capacity of lithium cobalt oxide also not a not good. It is almost practical capacity is a 150 milliampere per gram. So for the high time hour, we cannot use for the charge discharge for the not more than the 5 to 6 hours. So we have to develop the other material which will be fruitful for the heavy electrical vehicles. So the lithium cobalt oxide. So when we make in the form of nanomaterial, it provides the most of the problem that it's a heavy, it will provide the high capacity because the short path length of lithium ions and electron transport will be short path length. Charging discharging process is very high, is high. So some of the problem can be resolved by to synthesize this cathode material in the form of nanomaterials. So uh, there are the different methods for the preparation of the nanoparticles, like physical method, chemical method, and biological method, such as mechanical method, vapor deposition method, spot deposition method, electrical arc deposition, ion beam, and molecular. These are the physical methods how we will prepare the nanomaterials. Chemical method such as co-preparation method, because I am a chemist, so co-preparation method, different salt we are using, they precipitate them, then we are using, we are separate, precipitate them, then separate by filtration, then we are using to so different calculations in the other form, we are synthesize the nanomaterial. Sol-gel method, microemulsion method, hydrothermal synthesis, sonochemical and microfluid synthesis. These are the chemical method. In biochemical method, we are using the different extracts from the plant, from leaf extract and stem extract for the preparation of the these nanomaterials. Synthesis using the various enzymes, synthesis using the various agriculture ways. These are the different types of method for the preparation of nanomaterials. So there will be few techniques for the. So I have been working on the lithium ion battery for the preparation of the lithium cobalt oxide. What I have discussed there, the cost of lithium ion battery is very high. The cost of lithium ion battery will be low if the manufacturing process is will be reduced. So I have been focused on the development for the lithium cobalt oxide. For that one, I have developed a new technique, flame synthesis method. Flame synthesis method. This is this first one. This is the simple technique. We don't use the any costly instrumentation is there. There is no instrumentation is there. Low temperature, less than 350, we can synthesize the nanomaterial, and we are easily doping the various materials to enhance the electronic conductivity surface area of the cathode material, and we can uh, obtain the large amount of material for the industrial purpose, and it is also possible to uh, develop the variety of size, nano size and micro size, and various shape is possible by this method, flame synthesis method. So this is the promising cathode material for the lithium ion battery. So now the work is focused on the polyanion cathode material. Lithium iron phosphate is commercialized in 1997, discovered by the J.V. Goodenough, who are also got a Nobel Prize for the lithium ion battery. So they are the different synthetic method for to development the lithium cobalt oxide. The commercial method is the solid state route. So in the case of solid state route, it gives the various multi-step tasks to develop these materials. So it involves various tedious work, long reaction time, high calcination temperature, and also with this some second phase. When we are using the solid state reaction, we have taken the lithium acetate, cobalt acetate, and then we have mixed up with the wall milling, by hand mill and other forms. So it takes a very long time to and we require the high calcination temperature for the formation of uh, single phase material, and also sometimes this can causes secondary phase of that material. So we just need a new method for the development of this lithium cobalt oxide. Also, we know that there is a different chemical method also there, just such as Sol-gel method, putridation method, and combustion method. So these method, these are chemical use, but in the case of solvent method, co-pressure method, combustion method, these also uh, better than the solid state method because they provide the nanomaterial side. But in the case of solvent, co-pressure, combustion method, they involve the various multi-step reactions. Such as in the case of solvent, we have to prepare the stock solution of the different metal nitrate ion acetate, and other forms. And then we have to use to evaporate the water. It takes say 24 to 48 hours. There are many steps there. So the problem is that we have to develop a new method for the fabrication of the lithium cobalt oxide. So we have developed the non-aqueous combustion synthetic method. This is also known as flame synthesis method. In this method, the beauty of this method is that we have just need a lithium nitrate and cobalt nitrate and just mix up in the organic solvent and put into the uh, hot plate within within 50 minutes we can get the lithium cobalt oxide nanocrystalline particles in a single electron. We don't not to use the pre-calculation for the evaporation of the gels and other organic and carbonate metal. We have it within 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 55 to 1 hour, we can get the nanoparticle. Just we have taken lithium nitrate, cobalt nitrate, just mix up in the 2-methoxyethyl sonication 10 to 15 minutes. Then it gives the clear brown solution. Then just heat up on hot magnetic state. It will take to 30 to 45 minutes. Just is a very large volume of flame is there and the materials will be one and the one powder is there. It is very nanocrystalline in nature without any calcination temperature, without any sintering. We have the nanocrystalline lithium cobalt oxide. This is also known as ultra fast automatic synthesis technique developed by our lab and this is also be in commercialized in because we have got a patent on that on this and it will be a copyright and it also be transfer technology will be soon. So with the comparison of these atomic flame synthesis, chemical route and conventional solid state, you can see that in atomic flame there is only three steps is there: dating, weighing of the powder dissolution into 5 to 10 minutes, then magnetic constant 22, 25 to 30 minutes, then directly we can get the powder lithium cobalt. But in the comparison of the chemical routes, preparation of the lithium cobalt stock solution, then we have to mix up the citric acid, glycine, urea for the as the oxidized fuel and then magnetic stirring for 8 to 10 hours. Sometimes it will take 20 to 24 hours. Then we have to remove the carbonous material and other organic species like glycine other form. It will take the pre-calcination step, then it takes the calcination step. In comparison with the solid system reaction, we have also a multi-step task such as hand and mechanical grinding of the mixture of these materials 2 times, 3 times, whatever the homogenization solution or in the state form. Then grinding again and again and again. It will take still lots of time. It will be sometimes 3 to 4 days for the preparation with the commanders. So this is the beauty of the atomic flame synthesis method. We can prepare this one is within 1 hour. These are the for the comparison, we have taken the lithium cobalt oxide and commercialized uh, lithium cobalt oxide from the market and compare them. This is the XID of the lithium cobalt oxide commercialized. This is LCOC and lithium cobalt oxide LCO8. So it will give the layered structure and with the high intensity peak of the XRDs. And we have also used the solid state NMR. In the case of material science, the solid state is one of the best tools for to determine the structural stability at a molecular level, and it also provides the study of the single phase material. Whenever we use the lithium 0 ppm or 7 lithium NMR, it shows that is the it is a pure material. It has not consist of the other secondary phase. So we use the 59 cobalt mass NMR also there. So it is also with almost 1400. So these NMR analysis also provide us that this material is single phase material and in pure phase material. This is the same analysis. The same analysis also used uh, for the surface morphology of the prepared particle and show the particle size of 0.8 to 3.5 micrometer. But in the case of zero commercial size, show the 0.8 to 3 micrometer size. We have also used the particle analytical size to determine the LC powder for the fibers, and this is also used with 200 to 300 nanometer particle size average size. This is the TEM analysis. Here we can see the particle size nanometers in this. Also use the TEM HRTM picture for the D spacing. This is the confirmation of the XRD of 104 plane, and it means the our material is single phase material and it is a very good in crystalline nature. And we also use the XPS analysis, extra photofluorescence spectroscopy, for the composition, determine the composition of the synthesized lithium cobalt oxide. As we can see, the lithium, oxygen, and cobalt is present in there. The it means the purity of the material, synthesized material. Also, we have performed the electrochemical performance. In electrochemical performance, we can take the initial charge and discharge curves. So, at
Excuse me, sir.
0.05, yeah,
Sir, we have time constraint. It's already 6 o'clock. Uh,
okay.
we also have
I will,
session.
okay, I will do it within 2 to 3 minutes. Okay.
Okay, thank you, sir.
These are the electronic performance where the initial charge and discharge curve is there. 0.05. Let's see, we can see that the synthesized materials of the higher capacity than the commercialized lithium cobalt oxide. This is the electronic, we are the electronic performance of that at various C rate. There are the various rate performance where we can see that the synthesized lithium cobalt oxide shows the better electrochemical performance than the commercialized lithium cobalt oxide. So I also said that we have to develop the new materials for the uh, heavy electrical vehicles. So we are replacing the lithium cobalt oxide and lithium iron phosphate. Now these two materials are commercialized. So for that purpose, we have replaced to phosphate unit by boron unit. So we have developed a new hybrid composite material, lithium iron phosphate and boron cathode. This material we have developed, and we have also patented this material also, and it has the property of the both lithium iron phosphate and lithium iron boron. It shows the both properties. That means it is a hybrid structured cathode material. It is useful for the lithium ion battery because it is a environmental friendly. It has a high capacity. It is a retention capacity and high capacity around the 189.8. We have it means it gives you 97% of the its theoretical capacity. It means it is a very good hybrid structure. So due to time constraint, I cannot discuss the more on this one. These are the uh, three and four patents are there on this material. So because we have developed the large and well material. So conclusion that we are using the lithium cobalt oxide and we have developed a new method, flame synthesis method, to synthesis the lithium cobalt oxide for lowering the cost of lithium ion battery. In the proposed method, we are not using any complex agent and oxygen fuel as um, glycine, urea, and other form we cannot use. We just mix up the lithium and cobalt, then we can just synthesize the metal within 1 hour. Cell combustion of the precursor form, desired precursor in single step calcination, and the whole process will be to 40 to 15 minutes. Same NTM analysis we have done. So in conclusion, we can see that the electrochemical performance of the synthesized lithium cobalt oxide is better than the commercialized lithium cobalt oxide. So if someone want to discuss with me or other time, we have published the most article on this method also. You can see that the on my research or other form. So we have published lots of article on there. So thank you for your kind attention. Thank you very much. And someone have any question and other query about this with nanometal and other energy storage form, then you can ask me.
Thank you very much, sir. Now we'll go ahead and take some time for questions. Participants may ask questions or type them into the chat box. Sir, there's a question. If a material above 100 nanometer can name nano.
Yes, if the metal is 100 nanometer, it's usually as a nanometer. If the nanometer is 1 nanometer to 100 nanometer. Have you stopped my screen here? Because I cannot see you.
So you're still presenting the screen.
Okay. I can see now. Okay.
So there's
Is it okay? Yes. Ask.
As UG students, could you provide us some higher studies in this field?
250 nanometer is not a nano. The size range is 1 nanometer to 100 nanometer. If it is more than 100 nanometer, it is not calculated. It is a micrometer in size.
So there's another question in chat box. As UG students, could you provide us some higher studies in this field?
Yes, of course. PG, MTech, and PhD, all those in nanoscience and nanotechnology. Everywhere is nanotechnology. If you are going to join the IISc Bangalore, IIT, and other good NIS like universities and colleges, you can get this course. In PG, you can get the nanotechnology, nanoscience field. You can, of course, you can. In abroad, you can find the various courses in nanoscience and nanotechnology. Also in IITs and NITs, they are running the nanoscience in various fields. You can take it.
Sir, thank you, sir. Thank you, sir. Thank you for your good presentation. And the work in lithium-ion batteries is also very excellent. Good work is there. Lithium-ion batteries. Sir, can you hear?
Yeah, I am here.
Thank you very much for sparing time with us.
Okay, thank you so much. So actually, my field is the energy storage system. So just I correlate with the nanomaterials.
Yeah,
So
yeah.
because the materials we are using the so energy storage system, we can use the lots of area I have discussed. So I have few slides for the lithium ion batteries.
Yeah.
So I have
So
I
maybe,
have that too because there are only UG and PG students, so they are not too good to show the research
okay.
there.
So any substitute for this lithium ion, any substitute may come for this lithium ion in future, more powerful than this one.
Yeah, maybe solid state lithium ion battery may be there. And
Okay.
sodium ion battery, magnesium air battery, there are lots of research are going on.
Okay, okay, sir.
So lithium ion may be substituted with the sodium ion battery and also substitute lithium ion battery because we are using the liquid
Okay.
electrolyte in there. Because the charging and discharging process, there is a cycling. So the capacity is fading during the charge and discharge. But in now there is a research going on the solid electrolyte and
Okay.
that during the discharging, the battery capacity is not failing because whenever you use the 1 to 2 year, the capacity of the lithium ion battery is failing.
Yeah. Okay.
And
Okay. Thank you, sir. Thank you.
okay, is there any more question?
So there was a question in the chat box. For studying the optical thermal properties of nanoparticles, nanofibers mainly, what methods can be used?
What can I see the chat box? What is the question?
For studying
Pardon?
the optical thermal properties of nanoparticles, mainly nanofibers, what methods can be used?
What method for the you can use for the nanoparticle? Say you time analysis, atomic force microscopy. You can use this physical characterization.
Sorry, sir, will you please repeat?
You can use the time analysis, AFM analysis, and you are also using the XRD diffraction pattern for the nanoparticle studies. You can determine their nanometrical particle size from there.
Okay,
Is there
Sneha.
another one?
Sneha, then if no question, let's wind up.
Okay, sir. A big thanks to you, sir, for your efforts. The session was highly informative. Thank you for sharing your deep knowledge in nanoscience and nanotechnology. You gave us an excellent coverage to the topic. Thank you, sir.
Okay, thank you so much to all of you for inviting me.
So there is a vote of thanks session. So please wait. Please wait.
Okay.
Once again, reminding participants to fill out the feedback form available in the chat box. As we have come to the end of the webinar, I invite Cinda Esther Reggie, Chemistry Association Secretary, to propose the vote of thanks.
Respected and most distinguished chief guest of the day, Dr. Laxman Singh sir, respected principal Dr. Shaila Abraham ma'am, our beloved head of the department, Professor Vinita Voki, our chemistry association in charge, Dr. Thomas Baby sir, IQAC coordinator Lieutenant Rani sir, and all dear participants. It seems to be a great honor to propose the vote of thanks on this function. First of all, I would like to give my hearty vote of thanks to our chief guest, Dr. Laxman Singh sir, for gracing today's seminar. Thank you, sir, for your thought-provoking and informative class. I would like to express our deep gratitude, even in her absence, to our principal, Dr. Shaila Abraham ma'am. Thank you, ma'am. I extend my thanks to all the teachers of Chemistry Department of KG College Pampady for their cooperation and support. Also, I would like to thank IQAC Coordinator Lieutenant Reni sir for his presence and words. Thank you, sir. Next, I thank our association executives, especially association in charge Dr. Thomas Baby sir and all other members for making this event a success. Chemistry Association and Chemistry Department of Kyriakos Grigorios College, Pampady is very fortunate to have this audience from different colleges and universities. A special thanks to all the participants for your valuable presence. Once again, thanking you all. Have a great day.
Thank you, Cinta.
Thank you.
Thanks again,
Thank you.
Lakshman sir, for joining us today. Let us conclude this webinar. On behalf of Department of Chemistry and IQAC, KG College, Pampady, I thank you all for the participation and support. Keep learning.
Okay, thank you, sir. See you. Thank you. See you.
Thank you, sir.